Hey guys, welcome back everybody. Hope you all are doing great. Guys, this is part 6 of this network topology configuration, and now this network is live. Live means all end machines are able to access internet as well as they all are able to communicate with each other. Or in other word, you can say all end devices are able to access network resources. Network resources means, let's suppose I am hosting an application on a server. So that application is reachable from all end devices, from all departments. So you can verify the connectivity first, and many protocols are running in this network topology like NAT, IPSLA, HSRP, OSPF, VTP, DTP. Many protocols are enabled and all protocols are working fine, and machines are able to get IP address from the DHCP server. But again, we have some issues, guys. Later we will work on the improvement, how we can improve this network configuration. Now we don't have backup of configuration as well, so we will work on backup as well. Like we should have backup of each device. Then guys, I have only one DHCP server in my network. DHCP service is enabled only on distribution layer switch 1 on this switch, right? But if distribution layer switch 1 will goes down, then end machines cannot get IP address from the DHCP server. So we need to enable DHCP on distribution layer switch 2 also, or you can enable it on the core router, right? On any other device, you can enable DHCP. After that, in the last video, we had enabled remote service, right? We had enabled SSH on all devices, SSH, right? On router, firewall, on distribution layer switches, and on access layer switches. And see, I have some management PC. So from the management PC, you can access these devices remotely. To verify it, you can access any PC from the management domain like admin PC, and after that you can access any device. You can manage the configuration fine. So these all protocols are working fine. Now today we are going to understand some additional configuration on ASA firewall. See guys, many more configurations are still required in this network topology. Like you can see, I have server, and guys, suppose on the server I am hosting one application, right? So this server, on the server I have one application, and that application should be accessible from outside user, right? Means on the internet users should be able to access my resource, right? My application on the server one. So till now we have configured NAT on ASA firewall so that end devices can access internet, and IPSLA is also working. IPSLA is also working on ASA firewall to track the ISP, right? And ISP1 is the primary ISP, ISP2 is the secondary ISP. So until and unless ISP1 is up, ASA firewall is forwarding all traffic towards ISP1. If ISP1 will goes down, it will start forwarding traffic towards ISP2. So failover is also working fine. But the issue is outside users are not able to access my server. Definitely, because till now we didn't configure one-to-one translation, right? Right? For providing access to the internal servers to outside user, we need to configure what? One-to-one natting on ASA firewall, a static NAT, right? Or a static PAT. So we are going to configure a static NAT today on the ASA firewall so that outside users can access my server, right? And guys, on the server again we have, let's suppose, multiple services, right? But outside users should be only able to access 443 service, or let's say 80 service. So I'm going to access these two services to outside user. How to configure ASA firewall? How to configure ASA firewall to provide access to 443 and 80 HTTP and HTTP as to internet user, outside users, right? So we will see this configuration today, and after that guys, in upcoming video we will see many more configurations, right, in the scenario. Right now I am not working on the improvement, right? See, now I have configured the scenario so that my end users can access internet, and I have configured failover as well, right? To verify the configuration, simply you can access any PC, let's say PC1, and on the PC1 I can say IP DHCP. Guys, if you are not watching videos in sequence, then please watch first previous videos. so that you can understand the previous configurations, right? Because many protocols are running. See, I'm able to get IP address from the DHCP server 192.168.1.1 and gateway IP address 192.168.1.1, right? Virtual IP address with the alpha patches RP 192.168.1.100. You can see I'm able to ping my gateway IP address. And guys, I can access internet as well. Let me show you. Ping 8.8.8.8. You can see I'm able to ping internet. And ASA firewall is forwarding traffic towards ISP1 because ISP1 is up. So what we can do, we can check. Enable password is, you can see for SSH, my username is admin, password is pmnet@123, and enable password is cisco@123. So enable password is cisco@123. Let me put the password here, cisco@123. Now I have access of ASA firewall. So route include 0.0.0. So you can see right now ASA firewall is forwarding all traffic towards ISP1, right? Outside ISP1 is the name if of G0/0, which is connected with ISP1, and outside ISP2 is the name if of G0/1. So run interface G0/0. You can see the name if over here outside ISP1 and name if on G0/1 is outside ISP2. So right now ASA firewall is forwarding traffic towards ISP1 and my all end devices are able to access internet. What will happen, guys, if ISP1 will goes down? Let me check failover is working fine or not. Config T interface F0/0 and say shutdown. I have done ISP1. Now once ISP1 will goes down, on the ASA firewall, guys, track will goes down. So on ASA firewall you can run command show SLA monitor and operational state. You can see this timeout occur will become true first. Once it will become true, just wait for some time. We can reduce this timer by configuring frequency threshold, these things, right? Timeout, you can see now timeout occur is true, so my track will goes down. So track is now down. And guys, when track will goes down, what will happen? So route include 0.0.0. Now you can see it have install default route towards ISP2. Now ASA firewall will forward all traffic towards ISP2. Again, you can verify the connectivity from PC1. Let me ping 8.8.8 and you can see again ping is working. This time I am pinging 8.8.8 via ISP2. Internet is reachable via ISP2, right? But again I am going to up my ISP1 because ISP1 is up, guys, here. So let me run no shut command. The issue is what? Outside user cannot access the server, right? Outside users cannot access the server because see on ASA firewall, so run NAT, guys. So we have two NAT statement on ASA firewall. NAT inside 2, outside ISP1, then inside 2, outside ISP2. So all the traffic moving from inside to outside, we have NAT. ASA firewall will perform NATing. So NAT. So NAT. So see, guys, and both statements are under section 2 because this is auto NAT. That's fine. End devices can access internet and end devices are able to access internet. But can outside user access server? No. So let me check first default route. So route include 0.0.0. As soon as a firewall will install this default route towards ISP1. Now you can see toward ISP1. Now let me check. Let me do one thing. Let me configure first one IP address to the server, like this server 1. On this server, let's suppose I have one application, right? So guys, on the server again I am going to say IP DHCP, and this server VLAN 40 is the server VLAN. So this server is in VLAN 40. So it will get IP address from 192.168.4.0/24. And see, server should have a static IP address, or you can configure DHCP server so that it will provide only, let's say, this IP address. this IP address to server, because you have to fix the IP address on server. Reason being, you are going to configure NAT on ASA firewall for the server, bidirectional NAT, right? So to configure bidirectional NAT, I am going to use this IP address. Let's say this is IP address of my server, and see, server is also able to ping internet, ping 8.8.8. Yes, it is able to ping. VLAN 40, users are able to access internet, but can outside user ping internet, sorry, can access my server? Definitely no. See, from the ISP, if I will ping 192.168.4.1, ping will not work. By the way, this is the private IP address, so you can outside user can access my server with the help of public IP address, correct guys? So first of all, I have to decide one public IP address for my internal server. Let's suppose the public IP address for the server is, this one, 1.1.1.2. This is the public IP address for server, right? Now I need to configure a static NAT on ASA firewall, so that whenever outside user will ping or will send traffic to this IP address 1.1.1.2, ASA firewall is going to translate it into the private IP address of server, which is 192.168.4.1. But again, issue is what? Okay, if you will configure a static NAT to on this interface, on G0/0 interface, then what will happen, guys? Outside user can access your server via ISP1, can access your server via ISP1, they cannot access via ISP2. So what will happen when ISP1 will goes down? Again, outside users cannot access internet. So here we have to configure two NAT rule for this server and two NAT rule for this server also. Done. Now without wasting our time, let's begin. This is my public IP address for server 1. Let me write here public IP server 1. This is the public IP address of server 1. Let me change the color also here. I'm going to set this color. Let's say public IP address of server 1 is 1.1.1.1, and for from ISP2, let's say my public IP address is 2.2.2.2. Via ISP2, outside user can access my server via ISP2 with the help of this public IP address. So now we have two public IP address for the internal server, and later guys I will tell you how you can configure single public IP address as well, right? So now let me access ASA firewall on the ASA firewall. On the ASA firewall, I am going to configure first object. I need to again create two object. One will match the private IP address of server, one will match the public IP address, right? One will match the private IP address, one will match the public IP address. So let me say object, the network, and the name of object is, let's suppose, private IP underscore server 1, right? And here I am going to define IP address of my server, private IP address 192.168.4.1. and as you can see, I am using this private IP address for server, right? But guys, if server will get IP address from DHCP, then maybe after some time it will get different IP address. So you have to bind this IP address for the server with the MAC address of server. Later on we will see that how we can bind this IP address for server 1. Now I need to create one more object here, object network, and then public IP for server 1, public IP underscore server 1. And here I am going to define 1.1. Let's say 2, 1.1.1.2. Hit enter. Done. So run object. You can see I have created two objects, right? Now guys, I am going to configure one to one NAT, means a static NAT, bidirectional NAT. So simply say NAT, and this time I am using manual method so that I can put this NAT rule in section 1, because guys, static NAT means bidirectional NAT is more specific than general NAT rule. So my general NAT rule is all end devices should be able to access internet, and that rule is in section 2, and I am going to put this specific rule in section 1. That's why I am using manual NAT. So NAT, then say inside outside ISP1 interface, and then say source static and the name of your object, right? So it is going to translate from which IP address. First here we will use public. One pool is this one, private IP underscore server 1, and it will translate into this. This is my public pool, so let me say public pool here and hit enter. Now so run NAT. So you can see guys, this NAT rule, I have added this new NAT rule on ASA firewall, and this NAT rule will translate traffic from inside to outside ISP1. It will match source from private server 1 and public IP address from this object, right? Private IP address from this object and public IP address from this object, right? Now can ISP1 or outside user access my server with the help of this public IP address? Public IP address is this one, 1.1.1.2. So let me try. Let me take you to ISP router, and this time I am going to ping to, let's say, 1.1.1.2. Ping is not working. Is ASA doing translation? Debug NAT 255, right? And now see guys, ASA firewall is doing the translation. It is translating 1.1.1.2 into 192.168.4.1. ASA firewall is doing the translation, right? But the issue is, by default, as you know, ASA firewall does not allow traffic from lower security level to higher security level, right? So security level on G0/0 is 0, and security level on G0/2 is 100, right? So we need to allow lower security level to higher security level traffic on ASA firewall. So simply what I can do, I can create one access list. Let's say access list, and which type of access list is required here? Name of access list first. So name of access list is, let's say, out in server 1, right? Access list out in server 1, outside to inside for server 1. This is name of my access list. Then guys say extended, and then permit or deny. So I'm going to permit. What protocol? So if you want to allow only TCP traffic, so you can say TCP, right? But this time I am going to allow IP all traffic. But as I told you guys, if you want to allow in the real time, we will only allow 443 and 80 port number. Only these two port number will be allowed. Okay, for now I am going to allow IP so that I can use ping, okay, to verify, but later on we will change it. Extended IP and then source. So source IP address is any, because anyone can access your server from the internet, so you don't know the source. Destination will be always what? 192.168.4.1. destination should be always 4.1. This is the private IP address of my server, right? Then hit enter. What happened here? Net mask 255.255.255. Out in server found duplicate element. Okay, so this command has applied over here. How we can verify it? We can run command show access list. So you can see this access list is available in the running configuration. Now guys, I'm going to apply this access list on outside ISP1 interface on G0/0 interface. So say access group and name of your access list. Name of your access list is auth in for server 1, and then in which direction, in direction, and after that on which interface. So interface outside ISP1. So now I have allowed lower security level to higher security level on ASA firewall. Now let me take you to uh, internet on ISP, and let me try to ping your internal server, my internal server, with the help of public IP address. Again, I'm going to ping 1.1.1.2, and you can see this time guys, ping is working. Now outside users can access your server, right? So here I can say source loopback 1. See, loopback 1. From the loopback 1 I am able to ping, means all outside users can ping to my server via ISP1. But still we have some issue. See, outside user cannot ping your server with the help of private IP address, but outside user can ping your server with the help of public IP address, and you know the public IP address of your server. Now what will happen if ISP1 will goes down? If ISP1 will goes down, interface F0/0 shut down, right? Now your end machines can access internet, no problem, because ASA is going to shift traffic from ISP1 to ISP2. But can outside user ping to your server from the ISP2? Can I ping this public IP address? Ping 1.1.1.2, and where is my server? Here is server 1. Ping 8.8.8.8. Wait for some time. ASA firewall is taking some time for failover. On ASA firewall, simply we can check routing table. So route include 0.0.0. So it is still forwarding traffic towards ISP1. So SLA monitor operation. Yes, now it will shift the traffic. Now you can see on ISP2, now your PC, your server can access internet. You can see I'm able to access internet, right? But can outside user access my server? See, no. And guys, when outside user is trying to access your server, will ASA firewall perform netting? Debug NAT 255. Let me try to ping again. See, no. The reason being, because when outside user is trying to access this IP address 1.1.1.2, see guys, on the first of all on the ISP2, this IP address is, there is no route available for this public IP address, right? So like there should be connectivity between ISP1 and ISP2. There should be connectivity between ISP, and in the real time all ISPs are connected together, right? So this public IP address will be reachable from everywhere, right? So simply if I will configure one route over here on ISP2, I can say IP route and 1.1.1.2 255.255.255.255 255, and let me say what exit interface, let's say F0/0. Now can I ping? Not working. What will happen in this scenario? When I will ping to this IP address, ISP2 will forward traffic from their 0/0 interface, from their 0/0 interface. Source IP, any, let's say 8.8.8, destination IP, this public IP address. When ASA will receive it, it will receive on which interface guys? On 0/1 interface. On 0/1 interface it will receive. It will check what source is, sorry, destination is 1.1.1.2, and there is one netting, right? So NAT. So there is one NAT rule inside 2, outside ISP1. This NAT rule is matching 1.1.1.2. And guys, this NAT rule is matching that IP address on which interface on outside ISP1. But this time ASA firewall is receiving traffic on which interface on G0/1 outside ISP2. Correct? So that's why you can see ASA firewall is not doing translation. So what I need to do, I need to create one more pool here, right? Not pool, sorry, object. So say object network, and this time guys I'm going to define one another public IP address for ISP2. Let's say another public IP address for server 1 is this one, 2.2.2.2. So for 2.2.2 also I am going to create one NAT rule, right? So object network, and this time I'm going to say public IP underscore server 1 and say host 2.2.2.2. Done. On all. So run object. Now you can see I have public IP, private IP, and or is the new object? Yes, here public. Oh my god, actually name should be different. In this object I'm going to remove this command host. In this object host is 1.1.1.2, host 1.1.1.2, right? Now so run object. Now under this object you can see I'm matching this IP address, so name should be different. Like let me do one thing, let me say object network and public IP server 1 ISP2, right? And here I am going to define host 2.2.2.2 exit. Now you can check so run object. So you have now one new object where I am matching this IP address 2.2.2.2, which is the another public IP address on server. But guys, I must tell you this is the not method we will use, because maybe you are going to share only one public IP address, not no two public IP address. In this scenario, what will happen? You have to inform to outside user that these two are public IP address of server. Every time check first 1.1.1.2. If that IP address is not reachable, then check 2.2.2.2. Right? But why I am making this video, guys? Just to make you clear this basic concept, like how we are configuring, how we are creating bidirectional NAT, right? So on the ASA firewall, now I can say NAT inside outside ISP2 and source static, and after that name of your object. So here object name is, see, server private IP address of server is same, so I'm going to use same object, and the public IP address via ISP2 is this one, so let me use this name here. Correct? Done. Now what is the issue? Now issue is we have already one access control list here, so run access list, but that access list is running only on G0/0, not on 0/1. So we need to apply it on 0/1 also, because see, now from ISP2 again you cannot ping to this IP address, ping 2.2.2.2. See, ping is not working. Reason, ASA firewall is not allowing lower security level traffic to move higher security level, right? So this is the issue. Let me take you to ASA firewall, and here I am going to say access group, and the name of my access control list is auth in server 1, and this time again on in the inside interface. On which interface? On interface outside ISP2. Done. Now you can check from ISP2. From ISP2, am I able to ping the server? Now you can see I am able to ping the server, right? So guys, now what is happening in this scenario means user on ISP1 can access the server with the help of this public IP address 1.1.1.2, and user on ISP2 can access my internal server with the help of different public IP address, which is 2.2.2.2, right? So actually this was a basic configuration of bidirectional NAT on ASA firewall, and guys, this was required in this topology, in the scenario, and later we will see many more improvement, and still many configuration are remaining in this network topology, right? So we will see those configuration in upcoming videos. That's all for today, guys. If you have learned something from this video, please hit on like button and make sure you are watching all videos in sequence in this series. Okay, if you have any question, any concern, if you want to implement any other protocol in this network, you can let me know. You can just type your concern in the comment section. I will implement that protocol also. Okay, so that's all for today. If you have learned something from this video, please hit on like button, guys, and if you want more videos like this, please type yes in the comment section. As I am telling you again and again, your yes is motivating me to make more videos. So if this type of videos are helpful for you and you want more videos like this, just type yes in the comment section. Last thing, if you are new on the channel, please subscribe this channel. We will meet soon in next video. Till then, stay safe. Bye bye. That's all.